So for today's daily AP Chemistry challenge, the question is identify the most likely element using the mass spectrum. So they give you a mass spectrum here. On one end, you have the mass to charge ratio, and on the other end, you have intensity. It gives you the mass of those two peaks as well as the intensity of those two peaks. So if we start off with looking at what's given to us, we see we're given a mass spectrum. Here we have our mass to charge ratio on one side and the intensity on the other. So it's really important that it's given us intensity and not percent abundance. So we have our two peaks here, and we are given the intensity for both and then also their weight. So in order to discover which element makes up the mass spectrum, we need to ultimately find its atomic mass. So by calculating the atomic mass, we can then look in our periodic table, see which element has that specific atomic mass, and then that is going to give us the answer. So the atomic mass we know is going to be the weighted average of both of our isotopes. So we have two here, one with 10.01 and then one with 11.01. So we're going to have to find the weighted average of those based on the percent abundance. That's going to give us atomic mass, and then we're going to figure out what element it is. So because percent abundance is not given, we're going to have to find it out through the intensity. So we're going to have to find out our total intensity, and then we are going to have to divide our intensities for each peak by the total intensity, and that will give us the percent abundance. So the total intensity, so we'll put total intensity is going to equal 24.8 plus 100. So our total intensity is going to be 124.8. So our equation for finding the percent abundance is going to be the intensity of the isotope, so a singular isotope. So intensity of the isotope divided by the total intensity and that is going to give us percent abundance. So we already know what our total intensity is, and then we're given the intensity of each isotope here, so one being 24.8 and one being 100. So let's solve for our percent abundance. So let's start off with peak A, always keeping it organized. So we'll do A first, and then we'll do B. So A, its intensity of the isotope is 24.8, and we're going to put that over our total intensity, which we see here, which is 124.8, and that's going to give us percent abundance. So this is going to give us 0.1987 or 19.87%. So then for B, we're going to take our intensity for our isotope B, which is 100. So 100 over 124.8. This is going to give us 0.801 or 80.1%. So let's write these right beside our peaks and intensities so that we can keep it all organized. So for peak A, our percent abundance is going to equal 19.87. And then for peak B, the percent abundance is going to equal 80.1. That's in percent. And then we'll put a line here so that we can keep our peak A and our peak B separate. So to calculate the atomic mass, we are going to have to take our percent abundance and multiply it by the weight so that we can get the weighted average. So for our first one, peak A, we're going to take its weight, so 10.01 AMU, multiply it by the abundance in the sample. So if peak A, or the isotope for A, makes up 19.87%, we're going to say that it is 0.1987 as its abundance. So you would divide it by 100 because we don't want it as a percent. And my little trick for doing that is if you're dividing it by 100, you just have to move the decimal place over twice. So you can use the previous answer that we got earlier, or you can do percent abundance and then convert it back to its decimal. And then you're going to add your second. Then you're going to add the second isotope because you're trying to get the weighted average. So this is going to go 11.01 AMU multiplied by its abundance. So you have 80.1% of the sample, and that's going to give you 0.801 for the abundance. So we're going to multiply the ones beside each other first. So these two are going to get multiplied together first. These two get multiplied together first because of our order of operations. And then we're going to add them together, and that is going to give us our atomic mass for the sample. So 10.01 times 0.1987 is going to equal 1.988 roughly. And then we're going to add 11.01 times 0.801. And that's going to give us roughly 8.82. And then we add those together. And this is going to give us 10.8 roughly AMU for our overall atomic mass. So this should be the molar mass of the element that is showing this mass spectrum. So let's go to our periodic table. So now with our periodic table, we're going to look at which one has a molar mass of 10.8, and that's going to tell us what the element is. So if we zoom in here, we can see that boron has a molecular mass of exactly 10.8. As long as it's roughly close, you can assume what the element is, especially because this is a multiple choice question. So we figured out through our calculations that the atomic mass was 10.81. We go to our periodic table, we look for which element has an atomic mass of 10.81, which is going to be our boron. So we go back to our question. We look and we see that boron is one of our answers. So therefore, this mass spec is showing us the element boron.